So stoichiometry, what is it? How do you use it? How can it benefit you? To start, stoichiometry can be defined as the mathematical relationship between chemical formulas. It calculates the amount of reactants and products in a chemical balanced equation. So how do you use your chemical balanced equation in order to do stoichiometry? You use the coefficients. So the coefficients represent the number of moles in each compound and, in turn, each individual element within the balanced chemical equation. These numbers, or coefficients, are used as a mole-to-mole ratio in conversion factors for dimensional analysis. So let's take a look at some examples right now. First, we're going to look at propane plus 5 oxygens yields 3 carbon dioxides and 4 waters. The question is, how many moles of carbon dioxide are formed when 40 moles of oxygen is consumed while burning propane? So first, you know that 40 moles of oxygen are going to be consumed. So then you use the conversion factors of 5 moles of oxygen for every 3 moles of carbon dioxide and use that as a conversion factor. So in order to make the equation work, you have to put 5 moles of oxygen on the bottom, obviously. After this, we have 3 moles of carbon dioxide on top to let the moles of oxygen cancel out, and then you end up with the number of moles of carbon dioxide, which would be 24.0. Just as a side note, you must include the unit and the element or compound in order to keep track of what you're actually counting for. Let's move on to another example. We're going to start with 3 Fe solid plus 4 H2O gas yields Fe3O4 solid and 4 H2 gas. This means iron reacts with superheated steam to form hydrogen gas in the oxide Fe3O4. Now, what we need to calculate is the number of moles of hydrogen produced by 10 grams of iron in enough steam. So first we're going to start with the 10 grams of iron that we know we have. Then we're going to get that 10 grams of iron to moles. So you multiply that with 1 mole of iron over the molar mass of iron. That will give you the number of moles of iron in 10 grams. This is 0.179. So then after, we use the equation to find the conversion factor to get from moles of iron to moles of hydrogen gas. So as you see, there's 3 moles of iron for every 4 moles of hydrogen gas. Therefore, we can use that as a conversion factor and multiply 0.179 moles of iron by 4 moles of hydrogen gas over 3 moles of iron. This will yield approximately 0.239 moles of hydrogen gas. Time for one more example. So Fe2O3 solid plus 6 HCl aqueous yields 2 FeCl3 aqueous plus 3 H2O liquid. Iron 3 oxide, also known as rust, can be removed from iron by reacting it with hydrochloric acid to produce iron 3 chloride in water. So what we need to find: what mass of hydrogen chloride is required to react with 100 grams of rust? So first we need to get the 100 grams of rust to moles of rust. So we multiply 100 grams of rust by 1 mole of rust over the molar mass of rust. So that brings us to about 0.0626 moles of rust. From there, we can use the balanced chemical equation as a conversion factor. So first we see that Fe2O3, or rust, does not have a coefficient in front of it. That means there's 1 mole per every 6 moles of hydrochloric acid and 2 moles of FeCl3 and 3 H2O. So we put that in the denominator. Then for every 1 mole of rust, we find that there's 6 hydrochloric acids. So we use that on the top, creating our conversion factor. That yields about 3.756 moles of hydrochloric acid. From there, we need to get those the moles of hydrochloric acid back to the mass of hydrochloric acid. So therefore, we use the molar mass of hydrochloric acid over 1 mole of hydrochloric acid. That lets the moles of hydrochloric acid cancel out, leaving us with the grams which is 137 grams of hydrochloric acid. Now it's time for a little bit of a summary. So grams A to moles B to grams B is what the process you need to do, and the whole entire process, which you then can break down as need be for stoichiometry. So how do you get from grams A to grams B? So you have grams A times 1 mole A over the molar mass of A. Then you multiply that the moles of B over the number of moles A. Multiply that by the molar mass of grams B over the moles of B. Therefore, the grams of A will cancel out, the moles of A will cancel out, and the moles of B will cancel out, leaving you with the grams of substance B. You use the number of mole B over the number of mole A from the balanced chemical equation. Now you know everything you need to know about stoich to do any stoichiometry problem.